Welcome to class. What we just saw a few questions in Waec past question 2020 Waec. Alright, and this is within us tutorial. So we have some of our students live. So while we are solving, we're also serving the people online. Okay? So now if you look very well, you can see there are 5 questions and what we just quickly attempt those 5 questions. We hope that you're going to learn one or two things from this question. Alright? So just pay attention while we try to solve this question. So you look at them, we have the first question. Can we read together? Say, an electric device has a 50 turns in primary coil and 50 turns in what? In the secondary coil. The device can be A or an step-up transformer, step-down transformer, DC generator, AC generator. So now if you look at that question, if you can still look behind me, you can see that question we have what? A device that has 50 turns in primary coil and 50 turns in what secondary coil. For some of you, this question is very easy. Alright? Very, very easy. Why? Because when they say turns in primary and secondary coil, you have the what? You have the what? Is already a transformer, right? Once you hear turn, there is a transformer. But the options here, we have two options that are transformer. Is it a step down transformer or a step up transformer? Now, the step up transformer is a transformer that will increase your output. Alright? If you take a very small output and increase it, that's why they call it step up transformer. So what are the outputs? The voltage and the power. The voltage and the power. Okay? So how will you do that? It must have more turns in the secondary coil. Okay? So if the turns of the wire or the coil in the secondary coil is small, then it automatically is step up transformer. So let's assume that the primary coil has 5 and the secondary coil has like 100. So it's going to step up what? The output, the voltage or the power. Okay? So with that little explanation, our option is what? We have 50 in the primary coil and what? 20 in what? Secondary coil. 50 is more than 20. So our option is what? A step what? A step down transformer because we have 20 here in the secondary. So 20 is less than 50. So it's a step down transformer. I hope you get that answer clearly and the explanation clearly. Alright, let's move to the second one. The earpiece of the telephone converts energy from what? Electric to sound, sound to electrical, radio wave to sound, sound to radio wave. We're talking of what? The what? Earpiece. Alright? So, of course, when you plug your earpiece on, you are expected to hear what? Sound. Right? Good. And before it gets to your ear, it's coming from a device. Whether it has a cord that is a wire or not, it's coming from somewhere. Alright? And that thing that is coming from is not where the original sound is produced, right? The sound is coming from another place. Okay? So it means that for it to come from that device, your ear is moving electrically and giving you a what? Sound output. So it's moving from what? Electrical to sound output. So electrical to sound is the correct answer, okay? Good. I hope we understand this. Alright. So now we're moving to the next question. Two identical cups contain the same volume of water at 45 degrees Celsius and 5 degrees Celsius are left in a room at 25 degrees Celsius. Which of the following graph correctly represents the variation of temperature with time? Okay? So before we look at the graph, I want to give us a simple explanation. It's generally accepted that if a body is hot, for instance, water, if water is hot, okay, and you place it in a cold environment like your room, the room temperature is about 25 degrees Celsius. So let's say water has 100 degrees Celsius, and you put it in your room. After some time, what will happen? It will become cold. Why? Because it has lost the temperature to the surrounding. Okay? As air molecule begin to touch the part or the surface of the cup, it will begin to lose that heat. Okay? So it will drop from what? 100 to virtually the same temperature as that of what? The room. Are you getting me now? Good. So what does that mean? That means that if you place another cold water, let's say the water that has ice, and when water has ice, the temperature is far lower than what? 0 degree. But let's assume it's 0 degree. Alright? So at 0 degree, are you getting me? The temperature is what? Temperature is what? Far lower than room temperature. So what will happen? If you place a cup of ice, it will have to absorb heat from the external environment and thereby increasing the temperature to that of what? The room temperature. You understand with this explanation? We are expecting a graph of what? Something high coming down and something what? Low going up, and they will meet at the same point because the temperature will merge with what? The room temperature. Is that clear? Alright. So which of them shoot this illustration? Which of them should shoot this illustration? Is it A, B, C, or D? Now look at the temperature, 45 degrees Celsius going down to 25, then 5 going down, going up to what? 25, and they become the same. I think this is the perfect option, right? So A is correct. But other options, this one, it goes down and goes beyond. The 45 goes down and goes beyond. There's no time water will, from hot water to room temperature and go beyond. It can't become cool by itself because if it goes like this, it becomes cool by itself. It can't do that without a freezer, right? A freezer or a refrigerator, two of us. Good. So this option is wrong. So it can't be all hot and hotter than room temperature, right? It must need an external what influence, right? Good. The same thing happens there. All of them say the same story. This and this say the same story. But this one, it cannot remain what? It can't remain for 5 degrees without the influence of what? External environment, right? The same thing with this one. So the correct option is what? A. I hope you understand this now. Alright, so let's look at the number 16 question. It says, a ray of light traveling from what? From glass. A ray of light traveling from glass into ethyl alcohol is incident at the boundary at an angle of incidence 30 degrees. Alright? Calculate the angle of refraction. The very simple thing. Now I want to explain this, for a quick understanding before we go into something else. In case you don't know, this is under wave. And this wave is a property of wave that is called refraction. Alright? Refraction. Refraction simply means that the ability or the process of light to change direction when it's traveling from, let's say, air to water, or from water to air, or from glass to air. So light changes direction. Okay? That is why when you pick up a glass, I'm talking of a glass now, not a mirror, a glass. When the light is coming, or the ray of light from the other side is coming to where you are, you expect the light to appear somewhere. Alright? But it's shifting to another place. Have you observed it before? When you carry a thick glass, a block of glass. Instead of the light to come, because while you are looking at the glass, you are also seeing you know, the ray of light at the upper part where the glass is not, is not covered, right? So you are looking at it. So the normal ray is coming to your eye like this. But when you look below the glass, you are expecting the ray to also align with the normal ray. But it shifts or tilts towards another side. That is the phenomenon. Alright, that's the phenomenon. So light will always shift away, alright, when it travels from one medium to another. That process is called refraction. Okay? Now, one of the persons that worked on refraction is called Snell's. Alright? Snell have something to say about refraction. And Snell's law simply means N1 sine theta 1 equal to what? N2 sine what? Theta 2. That is Snell's law. Okay? So what is N1? N1 is the angle that the light is coming from. N2 is the angle that the light will shift towards, right? Are you getting me? Alright. Our reference point is the number, alright? Number. So let me draw a line so that you understand. This is the number, this is number line, alright? So this is medium 1, this is 1, and this is 2. Okay? So our reference point is the number, so this is what? Sorry, what did I say? N1, sorry, not N1, theta 1. I mean theta 1 is the angle, sorry, theta 1, please, sorry, not N1. Theta 1 is the angle that the light is what? Is entering, right, into another medium from, right? So this is the first medium, this is another medium. Why theta 2 is what? The angle of what? The second medium that is coming from, right? So we call this incident angle and this is refracted angle. Then the N is what we call refractive index. What's refractive index? Refractive index simply means the ratio of what? The angle of incident to the angle of what? Refraction. For different medium. For water, there is a different refractive index. For air, there is a different refractive index. Every medium has its own refractive index. So that means that the speed of light in every medium is different. We know that the speed of light in air is what? 3 times 10 per what? 8, right? But in other medium, it will be lesser or lower. Right? That's why we have different refractive index for different substance. But to solve this question, you can see refractive index for medium 1 and the angle of incidence for medium 2. Medium 1. The refractive index for medium 2 and the angle of incidence for medium what? 2. So, of course, on the side of the angle. So let's go. So what is the index for medium 1? So it's moving, first of all, it's moving from where? It's moving from glass into alcohol. So from glass into alcohol. So the angle of incidence in glass is 30 degrees. So the first refractive index we are using is for what? Glass. I get it 1.5 for glass. Then multiply by sine for what? Alcohol is what? Sorry, for the angle of incidence is what? 30 degrees.
Yes.
So 30 degrees. Are you saying it is 30 degrees? Look at it. The ray of light traveling from what glass into the alcohol into incident at the boundary of what? At an angle of what? Incident 30 degrees. So this is the boundary. So this is the angle of incidence. So 30 degrees. Are you with me? So the refractive index for alcohol is now what? 1.36. So we are now looking for what will be the angle when it comes out. Are you getting me? So from your mathematics, how do you solve this? You divide both sides by what? By what? 1.36 by what? Sorry, 1.36. 1.36. So this is how we cancel this, right?
Yes.
So what do you have now? Sine theta 2 is what? This divided by this sine 30. Sine 30 is what? 0.5. So 1.36 times 0.5. Sine 30 is 0.5. I hope you understand it. This one I've already cancelled this, so this is all we have. Look at it here. So this is what is remaining. 1.5 divided by 1.36. Look at the 1.5 divided by 1. Times 5, 30 degrees. Times 30 degrees is 0.5, okay? That is the value. So let's press our calculator. What do we have from this? At the end of the day, we have what? We have what? Okay. We have the calculator here. Let's try and quickly do this. So we have 1.5 times 0.5 divided by 1.36, and we have 0.5514. 0.5514. It's supposed to be 1.5 because when you approximate. So what we have? So sine theta 2 is what? 0. So when you now get the angle, how do you get the angle? Just find inverse, sine inverse of what? Of this value, 0.5515. So sine inverse of this value. Okay? So what is sine inverse? That will be our answer. So the sine inverse 33.5 approximately. Sine inverse is 33.5. Is there any option that has that?
Yes.
What option is that? Option B. So our answer is option B. Alright, so that is Snell's law. That's Snell's law. Snell's law, in a simple term, because Snell's law says that the ratio of the sine of angle of incidence to what? The sine of angle of refraction when light is traveling from one media to another is constant for any media or is constant for a given media. That's just a simple law for that. Okay? Alright, let's go to question 17. A very, very interesting question. Where are we going to solve this 17? So I'm going to leave this one there. Let's wipe this one off. If you want, you can always screenshot to see the better view. So let me solve that question at this point, at this place here. So what is the question? I will read together. A 60-kilogram man stands on a weighing balance in an elevator. If the elevator accelerates upward at what? 5 meters per second square, determine the reading of the scale. So I need to explain this before we solve. This question is very simple. Alright? It's very simple if you understand the simple concept. Let me start by layman understanding. What is layman understanding? Number one, most of you have climbed an elevator before. Alright? So when you are in an elevator, you discover that there are two different feelings you have. Alright? Two different what? Feelings. When the elevator is going up, and another one when the elevator is coming down. So when the elevator is going up, you want to enter a supermarket, you enter elevator. When it's going up, you discover that you feel heavier than normal, two of us. Let me use layman understanding. Since we have not really explained the very well, I want to remain in the layman level. So let's use the layman level. Okay, you are heavier than your normal, right?
Yes.
Good. So let's use the layman understanding. So since you are heavier than normal, it means that there is an additional weight taking you, right? That additional weight is as a result of this acceleration. Where is it? It's as a result of what? This acceleration. Where is the acceleration? Look at it. 5 meters per second square. This original acceleration is the weight, right? Acceleration due to gravity, right?
Yeah.
Now, this additional acceleration is because of what? The elevator is going what? Upward. Are you getting me now? So therefore, what we now have is that the resultant effect is what? The resultant effect is the what? The weight plus what? The weight, the force as a result of what? The elevator going upward. Are you getting me? The additional force that is added to you. Are you getting me now? Good. So let's calculate it. So the weight is mass times acceleration with gravity. And the force is the same mass, your own mass, and the acceleration that is added, that acceleration of going upward. Are you getting me now? So you can see your mass and this acceleration and your mass and this. Just understand that there's an additional weight when it's going upward. Just a layman understand there's an additional weight when it's going upward. And that additional weight is as a result of your mass and the acceleration of going upward. Are you getting me? So when you simplify it, you discover that M is equal to G plus A. Eh? So what you have now, your mass is what? What is your mass? 60 kilogram multiplied by 10 plus the additional acceleration. What do you have? 60 times 15.
Yeah.
60 times 15. So 6 times 15 is what? 6 times 15 is what? 90, right? So 90, 0, 0. Alright? So Newton. So I think the layman understanding better because you must have a deeper understanding before you can calculate. So you can see this. Alright? So just know that as you are going up, you are feeling weight there. So it means that there's an additional weight in you. So that additional weight is as a result of this acceleration when it's going up. The acceleration when it's going up. Are you getting it? So you can see that. So you can always use this formula to get anything you need in case if they ask you otherwise. Are you getting me now? Okay. So this X represents the force of going up. Like they are throwing you upward. Then this W represents what? Weight coming up. So I think this one should also be the weight, the tension on the spring. So the tension on the spring, yes, the tension on the spring. So what is measured by what? What is measured by your mid balance is what? Is what? 90 what?
That was great.
900 degrees. You understand this?
Yes.
Sincerely. Eh?
Yes.
Alright. So I think that's all for today.
Thank you.
So we're going to bring more calculations like this and also take topics on their own and solve questions under them as we have done before. So please try and follow, invite some people so that they can follow, and like I said, we want to have more live class. That will benefit us, live class, so that you can do in your live questions. Alright? Then, whenever you see me like this, just know that we are here to solve problems, no capping, there's no additional stress attached. Just to solve your problem so that you can score very, very high score. And that will be your portion. God bless you.